look at the top of your notes. Do y'all know what an absolute value does to numbers? Any of you? I know we've used the word a million times. No? Anybody? Okay, so absolute value always turns numbers positive. Okay? So it makes your interior value positive. So if you are asked if a particular point is a solution, you would still plug it in, okay, just like on normal equations. Okay, the only difference is that when you plug it in, the absolute value turns whatever is inside it to have a positive sign. So when I'm plugging into this equation right here, what would I put where y is? 5 less than 1/2. Then I get to an x. What would I plug in for x? Okay, -1 minus 3 more plus 6. Okay, in your PEMDAS, okay, remember that tells you the order that you're supposed to do stuff. Okay, in your PEMDAS, the absolute value functions kind of like the p, okay, in terms of order. So you would need to figure out what that is on the inside. What is -1 minus 3 more? Okay, so you'd have 5 less than half of -4 plus 6. But then what happens is that those absolute value bars take whatever is inside them and they switch it to a positive. So if this is a -4, because of these bars, not anymore. It turns positive. What is half of 4? 2. What's 2 plus 6?
3.
Is 5 really less than 8? Yes. Then is it a solution? Yes. Yes. If it's already positive, you just leave it. So that's a good question. It doesn't turn anything negative. It just turns negative stuff positive. If it's already positive, you leave it positive. Okay?
Where the fraction would actually be positive?
What's half of 4?
Oh, that's when you divide.
Yeah. Yep. Yeah. When it's inside the bars, it always turns positive. Okay? All right, look at the next one. We are going to graph inequalities today. So the first thing you need to do is get y by itself. Okay, then when you graph your line, you have two choices. You could have a dotted line or a solid line. Okay, your dotted choices would be either of these two. Your solid choices would be either of these two. Okay, and this is kind of throwback because we've actually covered this before, but with lines instead of V's. Okay, then when you shade your region, you're going to shade above the border if it's one of these guys. You're going to shade below the border if it's one of these guys. Then remember that solutions would be any points that are found either in the shaded area or on a solid line. Okay, so if it's in the shading, okay, can you just put that up? Because I don't want you to get behind. Okay? The shaded area or a solid line, those count. Okay? So look at number 1. Okay, the majority of this is very similar to yesterday. We should know how to graph this from this week. Okay, where is my vertex going to be if I have a -2 in the bars and a -3 at the back? +2, -3. Very good. You change the sign on the one with x. You leave the second one the same. Okay, so I'd go to 2, -3 on my graph here. 2 down 3. Then my slope is going to be 1/1 since nothing's there. So I would start here and go up over 1, up over 1, up over 1, up over 1. It is still going to be a V, yes ma'am. Then I would go up and the other way, up and the other way, up and the other way. Okay, here's where it's a little bit different. This is not an equal sign. This is a less than sign. So for a less than, look at the notes that we wrote. Is that going to count as a dotted or a solid border? Dotted. So I would go in, put a dotted line for my V. And then from there you have to choose where you're going to shade, but remember it's the same rules as last time. You're just shading above or below a V instead of a line. So if I'm looking at that same symbol, this is a less than, where am I going to shade? Below. So you would shade all down here. Okay, then remember that if your point is in the shaded region, it counts as a solution. Outside of the shaded region, it does not. So for example, would this point right here be a solution?
No.
No. Okay, what about if I pick one down here? Yes. What about if I pick this one on the border?
Yes.
Only if it's a solid border, that would count as a no. Okay, remember, solid borders count. Okay, we wrote that right here. Okay, but dotted borders do not count. Okay? Go ahead and turn over to the back. We're not going to work all these examples because I want you to have plenty of time to work on your review.
We don't have to worry about like we just have to do
Well, on the next page it asks about them, so that's where you'd have to worry about it. Okay? All right, turn over to the back. Look at number 3. A lot of these on your notes come out to be less than, so I want you to switch this to go the other way. Okay, we're making it go the other way just to make it to make it a greater than. Okay? So, look at number 3. Can we graph it right now? No, why not? You have to add the 1 across. Good job, Armando. So, plus 1 on both sides. These guys cross out. I have y greater than. Then I have my 2x minus 3. And then that was a negative 5, but I added 1. What is it now? Negative 4. What does that make my vertex? 3, negative 4. Good job, Sia. Okay, then from there I need to identify my slope. Look at the front. It's a whole number. What do I do? 2 over what? 1. Okay, so go to 3, negative 4. That would be right here. And then if my slope is 2 over 1, I would go up 2, out 1. Up 2, out 1. Then up 2, out 1 the other way. From there, you have the exact same choices that you had on the front. You have to pick what kind of line to use and then where to shade. What kind of line will we use with this symbol? Dotted. And then remember, we either need to shade above the V or below the V. Where are we going to shade here? Okay, we switched that to a greater than so that we would shade above this time. Okay. Then look at your question down here. This is the yes/no question that we were kind of answering on the front. It says, is 4, 0 a solution? Okay, well look at where 4, 0 is. That's right here. Is that in the shaded region? Does it count then? Yes. Okay. All right, jump over to number 4. What do we need to do to solve on number 4? Divide by negative 2. Okay, does anybody remember when you divide by a negative with inequalities, what has to happen? Good. Okay, so I'm going to put, okay, when you divide by a negative, you have to flip the symbol. So even though this one started off as a greater than, when I divide by that negative 2, I have to switch it around to be a less than. So y is still by itself, but it goes that way now. What was in front of the bars, even if it's not there? Okay, a 1, so now it's a negative 1 over 2. My x plus 1 in the middle stays exactly the same. What happens to my negative 6 if I divide it by negative 2? Positive 3. Then from there, you're just graphing. You would look for your vertex. Remember, you always change the sign here. Keep the sign the same back there. So it'd be negative 1, 3. Then I would put that on my graph. Negative 1, 3 is right here. What is going to change if my slope is negative? How is my V going to open? Down this time. That is only if you're plugging in numbers. If you're graphing, you don't have to worry about that. Okay? So, negative 1/2 would be down over 2, down over 2, down over 2. Same thing the other way, down back 2, down back 2, down back 2. Then from there I have to choose what kind of line I want to use. What kind of line do I want to use?
No, solid.
Solid. Look at your symbol right here. Okay, it does have an equal to on it, so that means that I would make a solid line.
Wait, hold on. Oh, you flipped this.
Yeah, because we divided by a negative. Okay, now this next question is important. Make sure that you're looking at the final version. Which way are we going to shade?
Up to on top of it.
We would have shaded on top, but what did we do?
I'm confused.
We switched it, so you're actually going to shade down. Okay, because remember, you're looking at this symbol right here.
Yeah.
That's a less than.
That's
Okay, so you want to make sure when you're looking to shade that you're looking at the last version of the equation.
So
Did you have a question?
Whenever it's the opposite.
Okay, so in the very front, remember when you divide, you have to divide 3 places. Here, here, here. Okay, but in the front, there was already a 1. So that's why it's 1/2. And then, Abraham, what was your question?
About that whenever the symbol is against the Y, then you shade inside.
I wouldn't think inside and outside, I would think up or down. So like this is the down part, that's the up part.
Okay.
But you could think of it that way, I guess, if you wanted to. And then 3-1, where does that fall?
On the line.
That's on the line. It's on a solid line. Does that count?
Yes.
Yes. What if it was a dotted line? Answer would be no. Okay, one more left that we're going to do. We're going to do number 5. Okay, look at it. First question, what do I need to do to solve on number 5? Okay, take away 1. I already had a -8. I'm minusing 1 more. What do I get now? Okay, so -3y, 6x, and now that's a -9 because it was -8 minus 1 more. Last step, I need to divide. What am I dividing by? -3. And if I divide by a negative, what do I have to remember? Okay, very good. Flip the symbol. Okay, I'm flipping the symbol because I'm dividing by a negative. So these guys cross out. Now it's y greater than or equal to. What is 6 divided by -3? -2. X is alone in the bars, and then -9 divided by -3. What happens there? +3. From there, I would graph my vertex first. If x is alone in the middle, what is the x coordinate? 0, 3. 0, 3 would be right here. And then from there, I would need to do my slope. My slope is a -2. Remember, that counts as over 1. Okay, Garrett, can you do this with us, please? Okay, so down 2 over 1, down 2 over 1. Then from there, you have to pick your symbol. What kind of line would we use here? Solid line.
Miss, why is it 0, 3?
Because there's not a number in there with x, so it's like x plus 0, basically. If there's not a number inside with x, you're not shifting it to either side, so you just keep it in the middle. And then the 3 moves it up 3. Yeah? So we said solid line, and then where are we going to shade? Make sure you're looking at the latest version of the equation above. If you're looking right here, okay, we can see that that's a greater than. What if you looked back at the very beginning, though? You would think it's a less than, and that would be wrong. Okay, so a greater than, you'd be shading everything out here.
So that's all along.
Okay? Then from there, we're asked about 0, 4. Is that a solution or no?
Yes.
0, 4 is right there. Is it inside? Yes. Okay. Alright, so tomorrow you have a quiz. So your homework is actually a review. It says review in the name. That means that it counts as a quiz grade. So if you're going to pick a day not to do your homework, don't pick today because it counts as more. Okay, switch to your homework. We'll do an example from each section. And then I'll let y'all work. Sure. Alright, look at the top 2. Remember, if you have a specific point that you are checking, you plug that point in to see if it's true at the end or not. So So xy, what would I write down if I'm plugging into this inequality right here? What's my y?
Y is 1. 1.
Right there, right?
Yeah.
So it'd be 3.
It's 3.
Okay? Then on the inside I'd have 2 minus, then I want to have x. X is 5 plus 3. Remember that the absolute value bars are like a parentheses. You have to combine. So what is 2 minus 5 in the middle? Negative 3.
Wait, Miss, why is it
Yes.
2 minus 5 if you have 5?
Because x is 5, so you're plugging in where the, like from the point right here.
Okay,
And then we're plugging in the 3 because that was in the y spot.
sure.
Okay? Then remember, what did we say the absolute value bars do to whatever's inside it?
Flip the sign if it's negative.
Okay, flip the sign if it's negative, so that would make this positive 3 plus 3. And what is 3 plus 3? Is 3 really bigger than 6? No. So then your answer would be not a solution. Okay? But if it came out to be true, then you would be fine. Okay? You would say yes. Okay, number 3 and 4 at the bottom. You should be shading. Notice you have symbols that are inequalities. Turn the page. We'll do one off the next page. Burkett, you said number 4? Okay. Look at it. What would we need to do on number 4 to solve here? Divide by negative 2. When you divide by a negative, what happens? You have to flip the sign. So these guys cross out. Y is now a less than. Is that just a negative 2 now in the front? No. Negative 1 over 2. Very good.
This confused me.
Okay, I'll come back to that with you. in
Negative
just a
goes
second,
on the
okay?
1.
It would go, well, it just, the negative is just kind of in the front. So if it's a 1 over negative 2, that's the same as negative 1 over 2. It doesn't matter where you put it. Okay? And then negative 6 divided by negative 2 would be a plus 3. Then from there, you should be able to graph that. If I have a x plus 1 and a plus 3, that means it's negative 1, 3. Okay, and I'm going to put a star here and write that we flipped it. Negative 1, 3 would be right here. What is my slope? Negative 1 over 2. Now, make sure, guys, it doesn't matter where you put the negative. That's what I was telling Burkett. If you put your negative on the bottom with the 2, as long as there's a negative there, your V should open down. So I would go down 1 over 2, down 1 over 2, down 1 over 2. Same thing in the other direction. 1 over 2, 1 over 2, 1 over 2. Then from there, we have a less than or equal to. That means it's a solid line.
Miss, why is that a negative 1? Oh, you should.
We divided by negative 2. So the 1 wasn't negative, but the 2 was. Because we divided by the negative 2 here.
No, the X.
Because remember, you always change the sign on that.
Yeah.
Where am I going to shade? Below. Now notice you got to be using that last version of the equation because it was originally a greater than, but it switched. So then I would shade down here. Okay? Alright, now look at 5 and 6. Okay, this asks you to graph absolute equations. Remember, an equation means that you have an equals sign. Should you be doing any shading on those questions? No. If it's an equals sign, then you are not shading. Okay, you are only graphing the V. That was what we did earlier in the week. Okay, so make sure if it's an equals, you should not have any shaded areas. Okay? Go ahead and turn the page, please. You would just only put the V, correct. We're going to do number 8 from this section. How would you solve number 8? Divide by what? Okay, negative 2. And now notice that almost always we divide in 3 places. What if there's nobody back here? Okay, you can put a plus 0 if you want and divide that by negative 2. But think about what is 0 no matter what you divide by. still 0. So if you want to just leave nothing there and just not put it, that's fine. Okay, but that would be the only case where you would not be dividing in all 3 spots. Okay, then I'd have a negative 1 over 2, x minus 3, and then I do not have a number back here, or you can write in a plus 0 if you want to. The what? The vertex would be what? 3, 0. Very good. Positive 3, 0 would be your vertex, and then what'd you say, Lyric? You're talking about here? Well, but remember there's a 1 on top, so that's how come it's a 1 over 2. Yeah, but that's the same. It doesn't matter where you put the negative. Because remember, guys, you could put the negative on the bottom, but either way that V is going to open down. That's what the negative tells you, is that your V is going to open down. So you'd go to 3, 0, that's right here. And then you'd go down over 2, down over 2, down over 2. Then you'd go here. And then remember, if it's an equals symbol, then you're just graphing the V and you're done. So line, line, finished. Okay? What is the very last thing that we need to do in this last section? If you're solving an equation, what do you do with the 2 sides of the equation? This is what we learned yesterday. You separate into 2 equations, graph, and see where they cross. So, for example, if I'm doing number 9, I would let y equal 5 from the first side. I would let y equal 1/2 x minus 3 plus 2 on the second side. And then from there you would graph your V and your line. Remember, we said yesterday that your number is always just a flat line across that value. So if it's 5, that would be right here. Where is the answer where they cross? Okay, my V, where would I start? If it's a minus 3, to the right 3 up 2, that would be right here. And then from there, my slope is 1/2, so 1 over 2, 1 over 2, 1 over 2. Same thing the other direction, 1 back 2, 1 back 2, 1, 2, 1, 2. Okay, now notice if it's asking you to solve, that means you can't just only graph it, you're using the graph to solve it. Remember, the solutions will be where they cross each other. So look at this first place that they cross. What x value is that? -3. What about this one over here? 9. And remember, you're always giving those x's, so -3 and 9. If you would rather not write the word and, I don't care, that's fine. You can do this, but do not put parentheses around it and make it like an ordered pair. Okay, that's wrong. So do not do this. -3, 9, like that. Okay, that is not at all right. So just don't do that. Okay? Alright, the next one we're going to do is number 11, then you'll have the rest of class to work. On the -3 side, what should we put for our first equation? Y equals -3 down here. Correct. There shouldn't be parentheses around it. And then -x plus 2 would be my second equation. So you're always just splitting up those 2 sides into 2 separate equations, then graphing. Now for my V, there is not a number with x. That means I don't move it side to side. I only go which way if there's a plus 2 at the back. Up 2. So it'd be up 2 right here. You could also think about that's like a 0, 2 for your vertex. And then what is my slope if nothing's out there? -1 over 1. Good. So I would start at that 0, 2 point, and then I would go down over, down over. Then I would go the other way, down back, like that. Good. Then those intersection points are -5, 5. Or you could put -5 and 5 is good. Okay? Okay, you get to use your review and your notes on your quiz tomorrow. And then remember to bring a book with you. Okay? You have 25 minutes to work.